one thing you may do for me, Estam.
What's that?
1 second, Estam. I just gotta do it once and last, because Estam, I need you to listen to me. Please listen to me, Estam. Please, I need you to just listen to me so you can do it perfectly for me now, quickly. Don't disturb you no more, okay?
I'm listening.
Oh, okay, Estam. I'm going to Japan for my PhD. I want to get all my family friend number, my dad number. Yes, to come from. Yes, I'm going to Japan. I'm getting visa to Japan.
To Japan?
Yes, because there's no house here for me. And Japan, I know Japan because I love Japan. I love kawaii. Yeah, but your number, I know how to call your number. I called Grandma number, but Grandma number not today. He's asleep every day. He's old man.
Okay, everything you want, text it on WhatsApp to me.
Oh, madam, Esther, can you get sit on the phone for me? I want you to sleep right now, Esther.
Just text it to me on WhatsApp.
Esther, I don't have WhatsApp. Esther, I don't have WhatsApp set up. Esther, I don't have WhatsApp set up.
No, you don't have. You have WhatsApp, but you blocked me. Unblock
No,
me.
Esther, listen to me. I don't have WhatsApp. I literally don't have it because my phone storage.
Oh, okay.
Just give me Vivian number and Vivian number and that number. That's the only number I need.
Why do you need their number? You don't need their number to apply for a visa.
No, because no. Look, Esther, I'm missing Dad. I'm missing Vivian. I don't give shit about Victor.
Your sibling's number, you want to write it where? For Japan?
No, because I just give them signal from Japan.
They're doing what?
No, I'm calling Dad in Japan because I call Dad. I don't call Victor, so I don't need Victor's number. I already gave Victor's number.
I don't have your dad's number. Call Vivian and tell us to give your dad's
number. Oh, Vivian.
Yeah.
Viviana.
Vivian, please don't put my number here. I don't know what you're talking about now. I don't know why you have to take people's number.
No, but Esther, I don't know to go to Japan. If you don't want to give it a fam, but I know your number because of this kind of conversation we have.
If you're going to
Esther, but you're the one to give me that number in the first place. Why you don't want to give it now?
I don't have it because I don't talk to your dad.
No, but I don't talk to you too, Esther. Esther, we don't talk to you too. You went to Japan. I don't talk to you too. I only call you for what I need. I don't mingle with you. Esther, I don't mingle with you. You know that because you went to Nigeria. No, Esther.
If you're applying for a visa, you just need your phone number.
No, Esther, I can go. Esther, I can go. No, Esther, you know the nest of king. My.
No, but you're trying to put everybody in the family.
No, okay, look, Esther, but that's not true. Esther, listen to me. Esther, listen to me. If it's fraud, it is fraud, that is not your concern.
Please send me copies of what. Please don't put my number there. I don't want it. I don't see why you.
Esther, I'm not asking for your number. Esther, I'm going there for my PhD because I don't have a house in anywhere. I don't have anything anywhere in the UK. I don't have anything for you. I haven't got money. I haven't got your time.
So is the university you are applying for?
No, Esther, I have a bachelor's degree in computer science. So I decided to come to Japan because they have basically the Japan system has social care system. Basically in Japan you have when you turn 18 you get house automatically. You have house right automatically when you come in. Basically, it's Japan evolves 3 times better. Basically Japan can give me house once I come there. But UK can't, so that's why I'm going to Japan because of my new divergence. But I don't have to go to Japan for that. Basically, I don't trust them because I've never even learned the language of Japanese people. But basically that's how they are there. So I'm just moving to Japan for my PhD, which is 3 years. Basically, UK one is 2 years, but PhD is 3 years in Japan. I just don't know why.
Have you got the admission?
Oh no, I have to pay for it. That's different. No. Esther, listen to me. Esther, if I give money, or if I don't give money, it's not your problem. Please understand that. If I give, I don't give, it's not your problem. You have house, Esther. You have house, so you don't have to give money. If I have to give money, I'll go through the legal process. Thank you, Esther.
I thought you have to get an offer letter.
Well, Esther, please, Esther, everything's online. Do you know that?
But you have to. Oh yes, they should give you an offer letter first, and you see what.
Look, Esther, Esther, listen to me.
Give you admit on fair.
Esther, listen to me. Esther,
How much is
Esther,
it?
what do you have an NVQ in anyway? A bachelor degree. What do you have a bachelor in? You know, you have to secure. No, Esther.
How much is it?
Esther,
you
don't
want to
start.
pay? How
Esther,
much is it?
Esther, listen to me. Listen to me now. Are you listening?
Answer my question.
Esther, I'm
You
not
know you
asking.
listen to me, but you don't want to answer my
Esther,
question. How much is it?
Esther, I'm not answering any of your questions. It's my personal life. Do you get what I'm saying?
Okay, then don't disturb me. It's your
Well,
personal life. Talk to me about life now.
Esther, I don't want you in my life. Esther,
can't want me to
you
give
are a
information, and
problem.
then you can't answer the questions
Esther,
that
you
me.
are a problem.
That's not possible.
Esther, you can end the call. I don't really care. Esther, I want you to leave my life. Please, end the call. Esther,
I'm living your life.
No, no,
I'm
Esther.
not disturbing you. You're the one calling me every time.
Esther, I called you because you have duty of care. You are part of social care. Esther, I don't call you.
You can get it in UK here.
Esther, no, I can't.
Anything you want, you can get it in
So I'm
UK
crazy.
Here. In Japan, you're not a citizen. In UK,
Oh, so I'm lying.
like a citizen.
So I'm lying. Esther, am I lying? Esther, am I lying? Yes or no? Is there somebody used to the question? Maybe I'm lying.
Lying about what?
I don't know.
Lying about what?
Well, the Japanese system. I don't know. Anything I've said. Am I lying?
You don't live in Japan. You
No,
don't
no,
live in Japan.
Esther.
You-
Esther.
you-
Esther, am I lying?
do PhD.
Esther, am I lying to you?
Where is the offer letter? Where is the admission letter?
Okay,
Where is
Esther, how did you get
Where-
Esther, how did you get from here from to here? Wasn't it from Nigeria? But you haven't anything to do with it.
Everything is not
Yeah.
right. You should have
No, no, Esther. Esther, so I should give you all my documents. So I give you all my documents. So you can all get me there. No. Esther, isn't it that you came from Nigeria? No, no, no. Esther, isn't it you came from Nigeria? You got your NVCQ. Oh, you got here and you did nothing. You got your bachelor. No, yes. Esther, you stayed in Oxford. You went to Oxford. You joined a nursing degree. You did nothing. You got nothing done. Esther, you had such a you had such a Esther, you had such a bright future. Esther, you have such a bright future, but you never did anything for your children. Do you know what I'm saying? You don't say. Do you get what I'm saying now? No. Esther, you had such a bright future. Esther, you came from. No, Esther, we know this. Esther, please. I'm an adult. Esther, I'm an adult. Please. Esther, I'm 24. Esther, so me giving you my information is doing this. Esther, please stop. Esther, me giving you my number, it's not okay for you to call me. Me giving you just my number, phone number, to call me is not enough for you to get me to Japan. No, Esther, please, a simple question. Me giving you my phone number to call me to advocate for me to Japan because you're health social care mom. Anyway. Okay, so this mom, wait. Anyway, let me call Vivian. Oh, Vivian, who's this? Norma? Who's this? Oh, Vivian. Hello, Vivian. Are you there? Sorry. Hi, Vivian. I need you to can you give me that number, Vivian, please? Please, I love you. Basically, that's number. I'm going to Japan to do my PhD. I got an offer there. But the offer is basically they have a health social care system there, but I don't have a house here, so I'm going to Japan for my PhD because Cambridge is not. I don't have a house in Cambridge. Basically, I'm 24 and it's supposed to be a free house if I turn 25. So that's a house in like 1998, and because I worked in Thurrock and health social care 2014. But I can get for free in Japan because Japanese has a better health social care system. Basically, Japan can give it for free because I'm doing a PhD. Yeah, but basically, it's they have a social care system, 3 years. So basically, listen, I'm gonna leave the UK, but I'm going to Japan. I'm gonna enjoy life a little bit. But the PhD is 3 years. Cambridge is 2 years. So Vivian, the problem is that I'm really kind of tired of money. Basically, I'm trying to save up money, but I've got silver of 10,000 already. No, I did it take 1,002 pence, 1,002 in my bank account. So good money there, but basically some of it's saving, and some of it's like used today. But that's not all I've used. So basically, I got some £500 to explain some money today. But basically, I have to go to Japan for my PhD now. Oh, I'm gonna do my PhD. Yeah,
Okay,
yeah.
I'll send you his number. I'm
Oh,
busy right now, okay?
Vivian, I love you. You're such a good sister. Vivian, what can I build for you? Do you want a fire suit? Can I? What do you want to be? Okay, Vivian, let me listen to you. Listen.
Nothing. I
No,
have to go,
no,
okay?
Vivian, please. What do you want? What can I build for you? What do you want? Vivian, please, let me answer this question, please, Vivian. Oh no.
Welcome to the EE voicemail. I'm sorry, but the person you've called is not available. Please leave your message after the tone. After you've finished your message, just hang up. Or to hear more options, please.
Anyway, so basically, today's video is really about family bureaucracy. So today's video is fire and forget. Forget and fire. Basically, forget if you forget something. You're basically if you forget something, you're basically if you fire something, it's fire. You fire shooting it, or you're shooting. You're destroying it. You're destroying it. But you're destroying it twice. So you're destroying it twice. You're actually not creating it. So if you destroy it twice, you can never create it again. So you have dimension for that. So you get the half. So if you half a dimension, if you half something, if you create something, you have to destroy it twice. Destroy the thing, and then destroy the environment for the thing. And you destroy it twice. That would be just D2, destroy times two. Because basically basically you can't create it in space it was meant to be facial, and that too can never be created again. So you gotta have a program use them. So basically you can destroy communication of a channel, and you can what basically find and forget protocol for no signal. So basically it's basically meant to destroy everything, even the protocol channel, and everything that's the waveform, and flood it with new noise, something they steal it, so a new noise into it, which is kind of funny because you have to implode it. So basically, that's something called an implode protocol. So when you forget something, you have to implode it twice. You just get it, you destroy it first, fire, and then you forget it. So you clear it. So you fire it and you clear the thing in the medium, and that's F squared. So F squared is like the fire and forget. But if you can fire first or forget first, whichever you want to do. You can destroy the alphabet by temporarily, basically the best way is to have a series execution step in this model. So you get the union disjoint property based on consensus modeling for radio channels. But I'm trying to literally design a fire suit, which is like basically go a Bunsen burner. Basically, go a Bunsen burner, but basically I'm trying to first find a new type of product fire suit. But I'm trying to run my body an igbo ontology, ontology of fire. So you like to have a mommy water, but I love mommy water. Mommy water is like the best igbo thing I've ever done. So you get if you create something, and you create again, you have some that can lasting forever. It lasts forever. The same opposite. So that's kind of idea. Yeah. So if you create them once, this is like a singleton pattern. So if you like have a singleton, which is an instance or class, single instance, when you destroy that instance, then you destroy the object. If you destroy the object twice, you are destroying the class. That's the idea here. So you destroy the class twice, and that's the full memory cleanup. But the class can be created. So you create a class with a functor. Basically, you can model the class as a function or functor, which is the same thing as the forgetting. And you can create an instance of the one single instance of that function, which is a functor, a mapping of functions. And then you have to destroy. So destroy the function again. You can create it twice. So you can create a function. You can create a functor, create a function called creator, and that creator will create a function, and that function will create another function. Two separate inputs, outputs that does different things. Two mapping to one, and that mapping via key value pair will then have the polar opposite, which is destroy. So destroy. So you get some kind of a rotation tree there. So you get two creates equals a one creator destroyer, one to one create and destroy, one to one create destroy. But two creators have a left pole of a left pole like a left. If I can create it, I can with 2c I can I can create a command. I can destroy it once, and I can destroy it again twice. I get but I have to go through two steps to one, based on the homogeneity and the heterogeneity first. Because if you map it twice to create, you have a singleton, and that thing can never shut down. Basically, this kind of a forkable process for macOS. You can fork this process, and you can transfer this project into a library, because you can bootstrap with this thing based on half row. So if you can do things to make it work properly, you have to half dimensions. For example, if you have a pi dimension, pi r squared, which is the radius 360, you have to shrink dimension into a library. So if you want to make this library, get 3 divided by 360 divided by pi. Now that'll be pi squared. Because pi squared is the thing. You get 360 divided by pi, and you have to get the squared, pi squared, and that'll be r equals pi 360 divided by pi squared, which is here. Phone calculator. 360 divided by pi squared pi times pi. Basically that's minus 304 degrees, which is the polar opposite of the, basically it's the inverse rule. Basically it's the polar opposite of the full unit of 1. Now this one, basically this is -1, which is the 304 degrees rotation for modeling this kind of destroy operation. So when I destroy once, -1, this will be -1, but this will be -2. So for this to be -2, I get 304 degrees rotation in opposite. This will be times 2. So times 2 this will be 4. That'll be 8, and that'll be 8. So will be 4, and this will be 248 degrees. So which would be 4. It was like a 2 units. Now you get 1 and 2, 1 and 2, and 4. Basically, if you have 1, 2 rotations clockwise, 2 clockwise, you get times 4, and that'll be like a 648 times 4. 648 times 4 is what? So basically, to get a full destroy, you have to get to rotate clockwise or anti-clockwise, depending on what the destroy means, what the homogeneous kind of curvature. If you destroy something, you get 2592 degrees of an inverse rotation, which is equal to 4 turns. Based on 90 degrees of rotation, pi over 360. The pi r squared equals 360, which is the radius, and the radius is unit. So you get the radius, which is 0 to 1, and you get the 0 to 1, and you get the pi, which is 3.14 for the canonical bubble. So if the radius shrinks, if the radius if I make the radius 0.314, this has to scale up to the precision because this maps basically if this has to map 0.1, 0.1, 0 to 1, and that's the perfect bubble in our universe. The perfect bubble. But we can do 0.000112, 0.003, 0.003. Because this would be the 110th of it, but 0.34 is good enough to do it. So let's do that. So 0.3414, 0.314, 0.314 squared times squared is pi over 360. So you get 360 divided by pi squared. Basically you get r. So you get pi squared will be 0.314 squared. And that'll be times 0.314, and that'll be 0.0098596. 0.098596. That'll be 0.08956, and that'll be 0.098596. Basically that's the unit model there, and you get times r. Times r would be the unit. Based on basically the unit is based on magnitude. So a0 to 1 is 360. That would be I can turn after map before I do I have to map the radius to the system. So if my state of 0 to 1, which I got a lot of looking at here, but I'm saying that if my radius squared is 0.095986, my pi squared is that. Then we get the radius of 0 to 1 mapped to the other of 1 to 0 mapped to 360 for the unit, and that will be 1 over 360, 1 to 0 over basically 1 to 0 anti-clockwise, clockwise and anti-clockwise conjugate, and that will be 90 degrees divided by 360. If you get 180 degrees divided by 360. And 160 plus 180 minus 180 degrees, and you get 1 over 360 2 over 100 degrees over 360, which is like the first unit. So if I do 1 over 360, I should get the calculate shading. So I have to find the average, and that average is the mean, which is like the maximum 180 minus 1. Which is like rise to the average. So you get the range, you get the calculate average median. So you get the average, which is the median, biggest minus smallest. So you get 180 minus 1, which will be 179. 179 divided by 360, which is biggest minus smallest divided by how many which is 2, divided by 2. This 174 divided by 2, and this will be 174 divided by 2, and that'll be 174 divided by 2, and that'll be 87. 87 is the canonical shear space of the system. Now, 87 degrees is a polar shared degree. So if I do 180 times 87, basically 87, that is for 180 over 360. That should give me plus or minus the opposite. Because that's degrees model. Let's say 180 plus 87 times 87 times 180 times 87 is equal to 0, because that's the kind of basically 180 times 27. So if we do 180 plus 27, I should get some 27. I should get the 257. But 257 divided by minus basically okay. If you get 370, 360 divided by 272. Okay, let's do it again. So I get 360 divided by 180 plus. Okay, let me just try 180 times 87. This would be 174. Now 174 is just a canonical number. Basically, you need to trim out the decimals. That's good. You trim out the units, the fraction. So basically, they have no pole. They can't fold back on because they are polar. They're polar configured. Which I'm trying to say is the polar configuration is aligned to the polar unit. So you can't get a number. So you can't get a unit that's outside that you can't process based on fraction. So you get the polar positive. You get positive negatives. A unit model. You get times multiply. All the operations you can do modular arithmetics, but they're bound by their modular inversely fractional coefficient. You have a fraction, and the fraction has to fold back into basically it's a number converter. Basically, it converts fractional numbers, all fractional numbers, into a set space. A set space, which is a canonical modular number, via number 3. Because number 3 is going. This is like the time. The time is now is 12. 12. The time now is 22, 10, 52. Now 10:52 is what 10:52 in AM and PM share a canonical state of 22, 52, which is this model of time is diluted. So it's diluted because you have 20 basically 24 hour basically depending on where you are in the world. Military time in the UK, US, and other time in that's done. The one we have a beer for now because I made it for constitution model. So you get the opposite one, which is the 12-hour clock. So 12-hour clock is telling the truth, the full truth, with no lies. But it's still fragmented because you have to because the environment around is fragmented because it's not really. But we're trying to get this down to 6 hours. So if you have this is basically a 2-to-1 mapping because you can use 12 to get 6, and 6 times 2 equals 12, and 12 divided by 2 is 4. It's like 12 divided by 2 is 12 times 2 is 6 times 2 is 12, and 12 divided by 2 is 6. 6, and that basically when you half 12, you get 2. So you do like other ones. You get 12 divided by 0.5, and you get 6, and you get 6 times 1 full whole, and half. And you large you have 60. It's not defining the. So if you 6 times by itself, so basically you have a pipe. So in binary form, this would be the conceptual time of 6 a.m. p.m. where constitutional time equals constitutional space equals the polar opposite constitutional space. For example, if you want to convert 12 to 6 hours, if you want 6 hours, 6 hours. If you have the day, 6 hours, 6 hours in a day, and 6 hours of time to do it. So if you want to relax all the day in a space 6 hours, you have space to do that. Basically, you have 12-hour clock. So basically, half day. For half the day, you relax. That's 6 hours working. Now 6 hours working a day is perfect. Now you get other 6 hours there to other 12 hours. So for you to do this effectively, you have to prioritize. So you want to rest for the rest first. So you get 6 hours. 6 to 2. You get 12 to 6. 12 to 6 hours, but you don't. So basically, you have the 2-to-1 mapping. So you have to practice 1. The first input into the first one you do is 6, and 6 resistance to 2. 6 times 2 is 12. So you have that 12 hours there. But you have to half the 6 times half of basically you have to practice the half first, and last to look at you practice whatever is less first, the minimum, and that'll be the half. 6 times the half will be basically 6 is in GCD of 6 is the GCD of 6 is what 6 has a tree of 3 and 2. So the green common divisor is 3. And then the 12 you get 12 which is like a shared of 6 and 2, 6 and 3, 6 and 2, and that'll be 3 and 2. Basically you get the right root 3 balanced. So basically for me to do this time with the union, so the union of 6 and 2 to share a GCD, a union of 3 hours, only 3 hours, 3 plus 3 equals 6. But they have to basically, if I want to start for 6 hours, you have to spend 3 hours of my time, relaxing, and a maximum of 3 hours working, 3 hours working and 3 hours relaxing, 3 hours working and 3 hours relaxing, relaxing, because you get 3 squared hours total, but you spend so you get 3 you spend 3 squared hours, which is 3 times 3, which is 9 hours. 3 plus 3. So this you get 3 plus 3, 6 is 3 plus 3 is 6 hours. So you get 6 hours, but you can do 3 times 3 there too, but you don't want to do that. So you get 3 plus 3 there to get 6. Or you can, if you want to come out from your other 12 hours, when you want to work, which is considered 6 hours there, you have what 6 hours there already. But you break it down into 3. So you get 3 hours on its own, which is 3 to the power 1. Because the share connects to 1, 3 to the power 1 or 3, and then you get down there. So you don't have to do it. So basically, the goal is to ensure no set of operators can perform the opposite LCM, local DCD, and what LCD averaging distribution via node, median, range, and mean distribution. Lowest common multiple, greatest common divider, and what? So the LCM of 6 is what? 12 is what? Lowest common multiple will give you 6 is what? Bubble up. Let's see. The greatest common driver 6. Those common multiples are 2 and 3. And that'll be 3 and 6, and then you get the greatest common divider of 12, which is like a 6 and 2. 6 and 2. Basically, 6 and 2, and then 2 and 3. Because they have key pairs. So the shared unit between GCD as a functor of LCM is kind of high because of a pipe operator. Now, this is a binary represents the time and the space based on the grid of concession time. The concession time is really the same time. The whole goal of this is concession time. It may not make sense to you now. I have to make it sense. Basically, in a military environment, you have to maximize squeeze all the time in the world. Basically, time is space. Space is time. You got space time. Space equals time. So that's it. So you don't have to be doing something that's useless or pointless in kind of a way of even if you're soft, because no matter since you're going to a war zone and you have the war zone around you, that's the space. But that space is equal to some time area. So like 6 times 6 parameter 6 you get 6 squared. That'll be a maximum of 6 squared. 6 is just a unit. 6 times 6 squared, that'll be 36. Now, 36 is an area. 36 is an area. But the area is bound by consensual time, the time you consent to search this space. Basically, if you're searching 1 unit at a time, it's like there's a grid model. So you can search in 36 hours. Because if you have 6 hours, you have like a 6. If you have 6 square, you have 6 minutes. You have like a 60 minutes. Let's say 60. Let's say 6 hours to search something in the zone of to search and find something in the zone of a grid of get 6 hours. 6 times 6 equals 12 hours maximum. 6 times 6 equals 36 hours. 36 hours maximum, and 6 plus 6 12 hours maximum. Sorry, 12 to 1240 hours maximum. Only the system start failing. Really failed the environment on the system. Just solve the problem. You don't have to waste another second. So you have to create a plan to fix the framework in half the time. So you have something else you're doing. That's the idea. So the half the time is like half the space. If the space is a problem, and half the space of a time ratio. So space first, time next, or half the time. Then it's space. You have to double one resource. So there's no wastage in the system. What is really more good? So, for example, if I half the space. For example, if half the space 6 squared, 6 feet squared, 6 feet squared, that'll be not foot, 6 feet squared, that'll be 6 feet squared. 6 feet squared, that is cubed. But the volume is 6 squared cubed. So you get operations that map to this tomographically. What do I mean? So 6 squared is 6 times 6 is 36. Now 36 times 6 is what? 36 times 6 is 216 centimeters, feet squared, feet cubed. Because then you get the other one, which is 6 times 6, will be 216 hours. 300. Okay, so you can have to basically the idea of this is to basically when you build something, or you don't break. Basically, when you create a time space, you have a time to do it. You destroy. You know, you can destroy it, but you want to distill the essence in the space. So if you have some kind of firefight, you know, you create something, a space, you can destroy the space. But if you want to polarize the space first, you want to keep the space, you want to basically listen, growth. So you create something, you build something, you repair something, you can rebuild it. Basically repair something, you can rebuild it. You can rebuild something, you can repair it. You know, you can basically you can repair something, you can renew it. Sorry, you can repair something, you can renew it. You can rebuild something, you can renew it. The idea is consensual. You're consensual. You know, this is space time, but this is just resources. Space time are resources that are there, but you don't have strong control of it. Basically, I'm choosing my military division. Basically, you got the mode, like, you know, basically the fighting zone. You get like you get like sweat. Basically you get like a sweat, the sweat. You know, the butterfly sweat or the dragon sweat. Basically, dragon sweat, or the sweat sweat. Basically, the sweat is a shell. The shell can be cracked, but you know that's his sweat. Sweat. So the butterflies, the wings don't have wings, but they can fall. They start falling to the ground, and when they hit the ground, they lose the aura. But you know, so you get blood, sweat, and tears. So you get sweat, you get tears, then sweat. You start to cry. So the dragon cries, the crocodile cries, who cries, and the turtles what? This is like Gen Z before for season crocodile tears. You get tears, then blood. Then basically tears. Basically, a lot of people gonna cry. A lot of people you can cry until you leave, you know, or you can sweat until you leave, or you can bleed until you leave. Blood, sweat, and tears. You know, basically I'm trying to close. Basically, I'm being Uche now. So basically, Uche is like handing the torch to Eze. So basically, we're in Water World. I mean, like in my head, I'm like we're in Water World. I mean, like, you know, basically Uche is handing his chair, his stuff to Eze. But this is what the Uche is created. So Eze takes the torch, and my dad gave me a torch. So basically, my dad gives his torch of BF World. His house the space equals the time. The time equals the space. You want to double the resource, whatever you're creating, and minimize whatever is destroying you. Which is what's gonna be fine. We're gonna find games, you know. But you know, I'm trying to literally just prototype a system where I have some kind of a zero component, which like the sort of space. So there's still example. I have a walkie-talkie. A walkie-talkie is a radio channel. I was going too long. Basically, a walkie-talkie is a radio channel. But the radio is walkie-talkie down. For example, the radio is there forever. Basically, you get a radio channel. Everyone gets a radio channel. But that doesn't give you, there's no consistency, anything. There's no way you can speak to people because it's all consistent. If you have a radio channel, a radio, you have also a phone, your personal phone, obviously your personal war radio, your personal phone, but a bridge. So you get dragons can use all the radios. If you're a consent-based dragon, to radio you can switch the wall. This is consent. There's consensus to the wall, but the wall consent is the consensus for the system. So if you are consenting to the radio wall, you're not consenting to the local phone, but you're doing something that can aid it. You know, so basically that's the idea. So you are so when you consent to the phone call, you're not as a public domain. But if you consent to the radio stuff, you have to military tech or war tech. No, that's war tech. I think in war tech. But as nsibidi, I really love. N for November, S for Sarah, I for Indigo, B for Bravo, I for Indigo, I D for Delta, I for nsibidi, N for November, okay. S for Sarah, you know. That's what I said. But you know, you have consent 2-to-1 mapping for that. So you know, it's a shared sparse state for people who actually want to do this stuff via consent. Consent is a kind of state of communication over critical channel. Basically, also what's the Bunsen burner one? Okay, the Bunsen burner one, I won't give it to that now. Okay, basically, yes, I'm gonna give it to that now. You see, yeah, okay. So basically, I got this one here. I don't need it yet. I got this one ready. So the Bunsen burner one, okay. What is it now? So you get a Bunsen burner. For example, you have a burner. What do you mean? You get some. So you get like an angle here. So this is like the burner. So basically, this is very important to understand. This is what I call a Bunsen burner flame. So basically, this is flame. Here is the red. Red is the hardest flame. Basically, red is the weakest. Blue is the hardest flame, which is the tip. Now the tip is a point. Now this is not the tip, but this tip is very unstable. because it's not like a flame. It's not like a burning flame. So the idea of this tip is literally to have it like a burning flame. So you have a tip that's dynamic, lattice, sparse, Fourier transform. So basically, this is a fire model. It's a fire plasmoid, a stable plasmoid that's fire. You can turn on, turn off. Basically, it's like I'm trying to build like some kind of armor that you wear, but the future form. The future aura. Basically, the armor is the fire itself, but that form is projected to the right way. So whenever I turn my fire on, basically it's the lightning bolt fire. Then basically I have lightning and I have fire. Lightning, so I have lightning, and the lightning is in my hand, but it doesn't burn me because I have a plasmoid that protects me, and that plasmoid aims and can fire. Like fire and forget. Basically, I'm trying to get trying to make a fire suit, but the fire suit is a plasmoid itself. So the fire suit is like the what's it called? The fire suit is what the flamethrower. So it's flamethrower suit, but basically it's fire. It's fire resistant, but it's not fire resistant. It's fire compliant. basically I'm trying to create a dynamic system based on pi r squared cubed, because the cube is the form of the volume, but it's not good enough because I want to make it 4. So the pi r to the power 4. Basically, if the radius is 4, r to the power 4. Okay, 3 to the power of 6 is the standard dimensions I need. But 3 plus 6 is what? 9. Not 6, 7, 8, 9. 9 divided by 2 is 4. Or 4. Now this 4, basically, as you get to pi raised to 4 power, so that would be radius pi to the power 4, and that'll be 97.490 913 approximately 134. 0.4 97.40901013, and that's permitted. That's basically pi to power 4. But basically that's the standard bubble. Basically the parameter, but this pi is 4 because you got pi r squared. Obviously you get pi squared r squared, but this pi squared is just like pi over 2. But this pi over 2 is the same as pi to the power of 2 in the inverse area. So it's even pi 3, so you get pi 4 because that is safe for the whole thing. Safe for the whole thing as a chemical thing you gotta operate on. So you get a pi 4. That means you have to scale. So 360 to the power of 4 with the unit 4 based on the polarity. So if I multiply this 4 to get the equivalent of the pi, that's 360 pi r squared. So r squared will be 360 times 2 times 360, which would make it canonical 0 2 1 6 720 degrees. Now 700 degrees is the standard I use for the form. We get 4 pi squared 4 over 720 degrees. Now 700 degrees is pi squared over 200, so pi to the power of 4 over 720 degrees on pi squared on pi for the radius squared. Which is like this is pi squared of pi to the power of 4 pi power 4 over 700 basically. The flame is memorizing some OBINexus registration function. Listen, the goal really here is to ensure the flame cannot damage the suit, and the suit cannot damage the flame. So basically it's a fire suit, and the fire suit is basically tomographic. So it maps to my area and irrespective of volume before it maps to any surface on my skin. Basically it allows me to braid fire. Basically the phenomenon of lightning bulb is because the plasma is unstable. So when it starts to unstable, you have to it's durable. The steel is durable. It's not fire resistant. It is fire, but it's based on water. Example, the water world in my head is basically I have nothing and everything. So this room is nothing to me. Basically, when you have a work environment, you have some kind of plasma system. So the room is empty. But this room is empty. It's a chamber. So it's a chamber that's empty. So even this pen can be a weapon, if I stab it, and I have to know that that pen is a weapon. So if I stab myself, oh, it's hurting me. It's a weapon. That's the kind of environment I want to give you guys. So if I'm hurting myself, I'm sick. I know I'm sick, because I know I haven't eaten. So this is my workroom. So there's no food here. There's no water. There's no food. There's no water, and there's no only no air. There's only air. Air to breathe. But the water's on the ground. There's water. The only thing that's there is the water on the floor. It's a wet room. It's a wet room with noise, with no signal, and signal compliance. You have the maximum signal because there's no other signal, so you get all signals. So any information that enters the room, basically what is sound, music, anything goes, and that's what basically this work environment. So the wet room is my war environment. So if I go to this room, the computer is wet. Because fire is things that come. If someone's trying to kill me, I'll know. Oh, they can use fire, but fire is the opposite of my environment. That I normally reside in. So this gives me the mind of training automatically. It's like a workroom, but the workroom is wet. But I don't mix the workroom with the communication room. Because if I see I need to communicate, because I'm working myself. But if they work with others, I can go in that shared space. That's the idea. So the wet room is like literally water well. So you get water, you can keep water, you can put water on the floor. But if there's water, that means it can slip. So I have to get some kind of wetness, something that's safe, safe water. And fishes, anything that can be imploding. So for example, based on my core, so implosion, I came from water, I come to air. Now air is my land. I come to land, but land is the medium of air. So I can learn to swim. I can have swimming stuff in there. But it sounds kind of intuitive, but it works for me because that's my embryo, that's my shell. What shell? Because I'm wet, I'm water, I'm 60% water, 60% water, and I'm not busy. If I'm a human being, I'm 60% water and 40% calcium. Other person's 40%, the rest is 40%. The bones. That's kind of thing I'm building. Because if I destroy the water, I'm trying to take the water and make it a fire suit. But this fire suit is powered by water. Things that are water bound, but they need something to ignite it. Because if the water is a fuel, if the water is a fuel, which is hydrogen fuel, you have to separate it from two. So you get H2. So you can get H. So if I buy H2 to 4, if I bind H4 is like the gas isotope based on charge. So if I charge it from the electrons by, if I have the H2O is water. So if I H4, if I change the isotope, if I configure the isotope of H2 times H2, I get some kind of isotope in H4 bound to O. Bound to O. When it binds to O, it becomes a fuel. For example, H2 times H2, H2 plus H2. So if I have the electron become H2, if I have the electron, which is negative charge, I charge it with positive 2, it becomes an isotope. The isotope is now some kind of gas, because hydrogen solid. Basically, you get hydrogen gas, you now get hydrogen vapor. Now the vapor is now sparse, so sparse. It has to condense. It becomes you size it into an state. So you size the ratio to 4 to 2. You give and start giving energy, start feeding some kind of system, because now the ratio now positively charged, because they have two negative charge. Basically, they're not neutral mode. But the neutrals are not there. So you get H2O, you get no nuclear. You get H2 electron squared. You get for the protons, you get you have to say the protons. Protons to apologize. You have the negative. You have to use you have to charge them. You can charge them with you have to get to the system to convert it safely from H2 to H4. And that'll be plus 2 proton and plus 2, making a pair of plus or minus 4, H to the power 4, which is shared to excite the system. And then that hydrogen will merge with some kind of water, which is distilled. Basically, the water is already there, but the hydrogen distills into the water. And that'll make the system like the war room, or the wet room. But if you want to switch to the other, if you want to get out of it, you have to go. You don't really know anything there. Has execution. It's a wet room, but it's a wet room for war. So when the water is not there, you have the water, but it's wet. But the wet room is water. So you get water when it's wet. If it's wet, you get water. If some works, you get a different environment. Different environment. And you can think you can work, but the environment doesn't fragment the whole ecosystem that's already there. So if it's basically, that's very important to understand. Basically, the war room is like a war room. So that's like a war room. So the war room is like for you to calm your own environment. But the best way you can do it is to ensure the war room doesn't contaminate with anything else. Basically, there's no fire involved in it. So you get H2O. So basically, if you get H2O, you can get H minus 2O, which is like a 0 0, minus 2, which would be like 0 electrons, 0 charges. This would be a gas, minus 2 and divide minus 2 and divide by 2. Basically, when you minus 2, you get 0 electrons. You remove the electrons, and you get minus 2. You get minus positron, 2 of the positron. You get the positron. You get the hydrogen atoms and isotope. Which isotope? So basically, it doesn't bind to anything. That is unstable. it stabilizes, and you get the opposite one, which is what you can do. You get the opposite one when you add it. Add the electrons, and you add the protons based on the pairs. You can add two electrons and multiply with 2, or you can at the maximum at the minimum locality to do something. Minimum 2 pair locality. So you get the opposite one plus or minus 2. Based on the canonical rules that apply in that environment. So you may think it's like counterintuitive, but people that try to navigate that to lose sense of direction. So basically, you get open sense direction. Basically, you get open sense motor. The motor is like open sense motor. So you get open sense signal, which is like I just guess it. I know understand what's going on. I understand what we're gonna do. Basically, if you get a open sense matrix, which is 7.7, which is the touch. But before I can touch something, I have to know I'm looking at it. Basically, get open sense motion. So open sense motion is what the motion. What I'm gonna do, my motion to see or see my observer state only, and then before I can act, which is the open sense flow. But in that bridge, before I can act, if I'm acting, if I'm in a motion about to act, I can get a signal before that. So that's the signal. What do I need to do before? What's my information before I do? So get open sense signal for me, myself, and I. Open sense motor, like a motor for motor linear, an open sense motion, and open sense framework. All together, open sense compliance stuff. Because the goal is to have the water, bro, be biological and biological, can make it you. No matter if like a child or anything, you think about your past. For me, it's about my past, my history, and all that stuff. And like, you need to think about the world differently. No matter if the cook that you don't want anybody swimming in the water, but you want people to understand this kind of way you navigate that system before the based on this signal. Basically, what is the imagine someone coming to your crib and they slip, and you just and it's all white. You think differently because it's security by design. You may think it's dirty or not, but no matter what is rock or bedrock, I wanted that. I needed that because I don't see bedrock as that kind of thing. If rock can balance, if can balance on the floor, basically I used to wear my monstulators. If I can wear my monstulators upright, as woke as a child, I should be able to do that as an adult today. That's what it means to me. So I've missed all my things in Nigeria, but these are things I want to do in Nigeria, based on how the system distills action via the lattice space. Which I mean that the system knows what it's doing because the space around me is ontological. It's a reference point for the lattice model, which is XYZ coordinate system, for row conjugate, and Fourier transformation based on the navigation of the system, mapped to convolution, conjunction for modeling systems of sparse decentralized tomography, which is bound to area. OBINexus system. Thank you guys. Like, share, subscribe, share if you want to. I don't really care.